In this video, we're going to explore organizing coordinate proofs as they pertain to parallelograms and special parallelograms. In order to take care of this, we need to refresh our memories of the midpoint formula and the distance formula. We'll be using these eventually when we take our proofs to a two-column proof and be able to prove things about midpoints and diagonals that bisect each other, distances, so we can prove that sides are congruent, that type of thing. But before we take our proofs to the two-column variety, we are going to take a look at just our parallelograms on a coordinate plane. So in this first example, we're given the coordinates for point A and point C, and we're looking for the coordinates of point B and point D. Well, I noticed that point A is hanging out at the origin, so that's at 0, 0. I notice that point C is hanging out at A, comma B. Now that looks kind of goofy, but think of it this way. I need to travel over and travel up in order to get to point A. I'm going to travel over A units, and I'm going to travel up B units. So if I want to take a look at coordinate B, I know that I need to move over to the right A units, and then I'm not going to make any sort of vertical change. So B is hanging out at A, comma, 0. If I want to figure out the coordinates for point D, I'm starting at A, and I don't want to go over any units, but I want to come up to this level, so I'm going up B units. So that coordinate is located at 0, comma, B. In this next example, we're looking for the coordinates of point C if we know that ABCD is an isosceles trapezoid. Well, if this is an isosceles trapezoid, I know that I have one pair of parallel sides, and those sides are going to be congruent as well to make it isosceles. If I take a look, point A is given at 0, 0. To get from point A to point D, I need to move over B units and up C units. So now I need to figure out how much from point B I need to move over and up to get to point C. Alright, since it's isosceles, actually let's just start with our y coordinate first. I notice that D and C are both located on the same level. It has to be parallel to this guy. So since these are even, I know that I'm also moving up C units. Alright. Since it's isosceles, I know that I must move backwards B units. So if I'm starting at A and I'm moving left B units, my x-coordinate is now located at whatever A is, and then subtract B to move it to the left, comma, I'm moving up C units. In this next example, it's very similar to the previous one. We're given that ABCD is a parallelogram this time. So I know top and bottom are parallel, and left and right are parallel. I know the coordinates for point A, and to get over to point D, I need to move over and up. So I'm going to move over B units and up C units. So since I have a parallelogram, I need to follow that same path, over B units, up C units. So I'm starting at A, and I'm moving right B units, so I'm going to be located at A plus B. And then how much do I rise up? I'm rising up C units, so A plus B, comma C. In this example, we're given quadrilateral PQRS, and we're given coordinates for each of those vertices. And it's our job to determine if we have a rectangle going on here. In order to do this, there's several different ways we can take care of this. We could show that, hey, all four of those are right angles, so we could verify, hey, do we have a perpendicular slope? Something else that we can do is we can verify that SQ is the same length as PR. So if we can verify that those two diagonals are congruent, that's one of our characteristics of a rectangle, so that would take care of it. So if I wanted to find the length of PR, I'm going to use my distance formula. So I'll think x1 minus x2 squared plus y1 minus y2 squared. And when I calculate that, I end up with approximately 9.22. All right, so now I'm going to take care of QS. I'm going to see if that length is going to be the same. So I'm going to take x1 minus x2, so 1 minus negative 7 squared, plus y1 minus y2, or negative 1 minus 0 squared. And when I calculate that out, I have approximately 8.06. I notice that this PR and QS are not congruent, so no, PQRS is not a rectangle. The diagonals are not congruent. All right, taking a look at this next one, we want to find the coordinates where the diagonals of the kite intersect. Well, if I draw my diagonals, here's one and here's the other. I remember with properties of kites that one diagonal bisects the other. So this piece here has to be equal to this piece here. So in other words, I want to find the midpoint of SV. So I'm going to add up my x coordinates, negative 4 plus 2 divided by 2, comma, add up my y coordinates, 2 plus 6 divided by 2. I can clean that up to get negative 4 plus 2, that's negative 2 over 2, comma, 2 plus 6 is 8 over 2. So I'm hanging out at negative 1, 4.